Hey guys, 9-7, factoring special cases. This is a fun section. Um, we're going to factor perfect square trinomials and factor the difference of squares. So basically we're undoing what we did earlier in this chapter. Okay, now remember if we had a plus b squared, let me see if I can get that highlighted. When we had this, we knew that we could write it out like that. And now it's the other way. If we are given a squared minus 2ab plus b squared, then we know we can write that as a minus b squared. Okay, so that's called the inverse operation. All right, example 1, factoring a perfect square trinomial when a is 1. So the first thing you want to do is look at your first term. Is that a perfect square? It sure is, because that would be m times m. And then 9 is also a perfect square. That would be 3 times 3. So multiply those two together, you get 3m. Multiply that by 2 because you have to double it. That's 6m. Does that match what we have there? Yep. And we know it's going to be minus. So this would be m minus 3 quantity squared. That's it. All right, let's take a look at one of the quick checks. Need to get that highlighter off now. Let's do, they're all the same. Let's go ahead and do B. All right, so is n squared a perfect square? Yes, it is, because the only way you can get n squared is n times n. And 64 is a perfect square. That's 8 times 8. 8 times n, 8n, times 2, 16n. So this is a perfect square trinomial. N plus 8 squared. That's it. All right, let's go ahead and go to example 2. Factoring a perfect square trinomial when your a is not 1. All right, so we're looking at this. Is 16h squared a perfect square? Yes. This is 4h times 4h. Is 25 a perfect square? Yes. It's 5 times 5. 4h times 5 is 20h times 2. Does that match the middle term? Yes, it does. So therefore, we have 4h plus 5 squared. And that's it. All right, another example. Let's do C. All right, 4t squared is a perfect square. That is 2t times 2t, or 2t squared. 81 is a perfect square. It is 9 squared. And the middle term is negative minus 9, so we know that's going to be minus. So we're going to write that as 2t minus 9 quantity squared. Multiply those two together, you get 18t, negative 18t to be exact, times 2, that's negative 36t, which matches what we have here, so we're good. All right, now example 3. The difference of two squares. This is probably my favorite by far. It's the easiest. All right. When you do not have a middle term, okay, so there is no middle term here. Check squares, especially if it's negative. So this would be the difference. Is a squared a perfect square? Yep. A times a is 16 a perfect square? Yep. 4 times 4.
Oh, shit.
A minus 4 times a plus 4. And there you go. So that would be the difference of squares. That's the only way you can get negative 16 would be a negative 4 times a positive 4. And that would also cancel out your middle terms. Okay, let's do one more. C, p squared minus 49. It's difference. Perfect square, p squared. Perfect square, 7 squared. And since that's a difference, you know you're going to have different signs. P plus 7, P minus 7. Now over here, you should get so good at these that you can just say, okay, the square root of 36 is 6, so x minus 6 and x plus 6. Okay, they should be fast. All right, now let's go ahead and take a look at the difference of squares when your a is not 1. This is easy. Same thing. What's the square root of 9b squared? 3b. What's the square root of 225? That would be 15. So since you have a difference of squares, this is going to be 3b minus 15 and 3b plus 15. All right, quick checks. 9b squared minus 4, 9b squared, square root is 3b, so that would be 3b squared. 4 is 2 squared, so that's 3b minus 2 and 3b plus 2. 25x squared minus 64, 5x squared, and 64 is 8 squared, so that's 5x minus 8 times 5x plus 8. All right, last example. Factoring out a common factor. This one is one that tricks a lot of people just because you think that you have to do more, overdo it, and you don't. When you only have 2 terms and it looks like there's nothing you can do, 5 isn't a perfect square, 80 is not a perfect square, see if they have a term in common. And in this case, they do. So I can factor out a 5 from both of these terms, and that would give me 5 times x squared minus 16. Okay, so this right here should be rating a red flag because you know that this is a difference of squares. So we can simplify that. This then is going to be x minus 4 times x plus 4, and don't forget to bring the 5 along. So this would be the answer, 5 times x minus 4 times x plus 4. One more, and then we will be done with this one. Let's take a look at, how about a, that one looks the trickiest. So we have 8y squared minus 50. Neither of those are perfect squares, and you cannot take an 8 out of 50, but you can take out a 2. So that would give us 2 times 4y squared minus 25. 4y squared, perfect square, right? That would be 2y squared, and 25 is a perfect square. That would be 5 squared. So we have 2 times 2y minus 5 and 2y plus 5. All right, there you go. Those are the special cases. Hopefully you like these better than you did 9-6. I know I do. If you have any questions, please see me.